Welcome everybody to the virtual lunch and learn meetup of the Microsoft Security User Group. This session is being recorded. So if you don't want to be on the recording, you can turn your camera off and mute. If you don't want to be in the meeting, you can drop out and you can watch the video again afterwards when we upload it to our YouTube channel. Today we have Erlend Rushfeldt from Atea, who's going to be talking about end-to-end API security with Azure API management and Application Gateway. Before we make a start, we usually just have some house rules that we need to run through. So first of all is our diversity charter. We're in an open community regardless of background. Everybody is welcome and everybody can share their opinion in the user group. That is not a problem at all. So welcome everybody. Some practical information regarding the meeting. We usually have the lunch session that lasts around 45 to 60 minutes. That's entirely up to you, Erlend, how you want to run the session. Up to you how you want to, if you want to take questions during or afterwards, just say. And then usually, we have a bit of time at the end for questions. You can also you can raise your hand if you want to ask any questions, or you can post some questions in the chat, and myself and the other organisers will try and facilitate that with Erlend during the recording. Everything's recorded, and then we share that also on YouTube, and the slides will also be provided Erlend's comfortable with that. We'll also upload that to our GitHub org repository, so you can download the slides for later. So, without further ado, Erlend, the floor is yours. Feel free to take over.
Thank you. All right, I'll just share my screen then again and start with a small presentation. Let's see. There you go. So today we're going to talk about API security and looking at Azure API management and application gateway with the web application firewall enabled, and how we can utilize those services from Microsoft to secure our APIs. So firstly, just quickly a short one about me. I work as a cloud advisor in Atea. I'm a former consultant before that, working mostly as platform engineer and Azure architect. I do a lot of talks on automation, governance, infrastructure as code, and cost management. So let's just jump right into it. I kind of hate PowerPoint, so we're going to be quick. It's only a few slides, and then we'll jump into the demo instead. So why does it matter if our APIs are secure or not? So if we don't secure our APIs, they can be utilized with possible exploits, of course, either in the frameworks that we use in the application or directly bad coding. And this is more and more common now because, of course, Copilot, vibe coding. I know a lot of people take pride in their code, and I'm not saying everyone is vibe coding, but we're seeing more and more of it. And because of that, as architects and platform engineers, especially, of course, developers can take that responsibility as well. We should look at how we can utilize services in the platform itself and not just in the application code. Also, we might have legacy applications that aren't a high priority to fix if there are security vulnerabilities or if it's outdated frameworks. Some might be using .NET Framework, for example, and old versions there that are technically out of support, but this core application for the organization might be too important and too much legacy to actually modernize. So there as well, we should utilize services in Azure to protect the application. So put protection in front of them or in between them and things like that without actually changing the code. And then the last one is that application-to-application traffic internally in a network might be used for lateral movement. If we don't have services that are created to secure these, we might just have a layer 4 network opening between them. Say it's just HTTPS. If you don't have a firewall, for example, in between them, if it's internally in a VNet, you might just get that layer 4 opening, and then the exploits might happen at layer 7 in the application level. So utilizing these services might help on that part as well, on protecting the services on layer 7 in addition to the layer 4 with the network. So how can we use them? If we publish the APIs behind Application Gateway and API management and utilize the policies on that, API management just calls it policy, and then in Application Gateway, it's a web application firewall policy. So they have a lot of built-in possibilities that you can use. They have examples on custom policies and things like that, and we'll look into that as well. You can also secure them by micro-segmenting your internal network, route all traffic through firewall, have segmentation that part, have traffic inspection. That can help a lot. And limit outbound network connectivity. One of the best technical presentations and demos I've ever seen is a friend of mine. He held a presentation called "Can a app service get a virus?", which was an example of how bad it can go if you don't limit the outbound network connectivity for your applications. It's a great presentation that he had, and hopefully he will hold it again. He's still doing security, so I hope to see it again. And then you have, if you, for example, have a cloud native application protection platform like Defender, you can utilize Defender for APIs. And we'll also have a quick look at that in the demo later. So just quickly on that. And then one question that I've gotten from a developer when we started looking at this was like, well, I can just implement these security features in my application. I'm a good developer. I can develop them in the application. Well, sure, you can, but that doesn't mean that everyone can. And there are benefits of using these Azure services instead of just coding the security features into every application that you have. And that is reusability. For example, with API management, you can add a policy that applies to all of your APIs that verifies the authentication and the authorization. We'll look into that in the demo, a simplified version, but you can both check on JSON web tokens or on straight up modern authentication and check that the token that it's getting, it is correct. It has the specified scope. It's signed with our key. You can verify that before you send it to the backend service. Now, of course, you can have it in the application code, but if you want to write that same code for all of your application, it might be too much duplicates. So it would be simpler to have it one place, and that is in the API management, for example. That is like the reusability, the central management of it. You can change it one place, update one certificate, and then it will work for your backends as well. Another part of this is utilizing Microsoft expertise and the scale. With a web application firewall, for example, you get Microsoft's security team in the backend. They will update what they see as common threats. They will update from open source libraries. They will find signatures that are common in use that they see in all of the Azure platform and all of the Microsoft services. We need to remember that the biggest customer of Azure is actually Microsoft themselves. So they are their own customer zero. They develop these security services for themselves as well. And utilizing that is such a big benefit that most people don't see, that it should definitely be something to convince you to look at these services. Now, as I said, now I put both central management and simpler management, but it's the same concepts there. So let's jump right into the demo. I have created a app service, a web app running Python fast API. I have deliberately created it as a unsecure code. It's really bad code. I forced Copilot at gunpoint to create me some bad API endpoints. And we'll look into that. We'll start by just looking at what happens if you just have the web app on the open internet and the endpoints can just be queried and executed. And then we'll move onto that, looking at how I've put it behind API management and looking at the benefits that we can get from there, how we can enforce authentication and authorization on it. And then lastly, we'll look at the last example, which is how we can put it when we have it behind an application gateway and API management and the benefits there. So go back onto the Azure portal. So here is my web app. Simple enough, no network limitation or anything like that, no authentication setup. It's super simple. And I have added the Swagger endpoint so that you can see that I have one just index on root. I have created just a super simple random fact one and a whether just have some get endpoints, and then we have a post endpoint, which is execute code. So this is on purpose a endpoint that can be used to actually execute code on the underlying application or the server. So let's look into that. I've created some fair enough, like easy queries in Postman, so we can look into it. The first one is just hit the random fact endpoint right here that we have. I have no body, no headers, no authorizations. It's just super simple open API here, and I'm getting a random fact. Okay, fair enough. That's not too bad. That could be intended. I want the endpoint to be like that. I want people to execute it and get their response to have their fun fact of the day. But what about that insecure endpoint that I had, the execute one? So here again, I have no header, no authorization. It's open on the internet, and the body here is actually I want to execute some code. So this code is super simple. It's some Python code to just list all the environment variables. And if I send that, I actually get a response in clear text, all the environment variables. And that's not good. I don't want that. That's pretty bad. So again, how can we utilize different services to actually protect against this one? So going back to the Azure portal, I have set up a API management service. So here I have super simply imported the Swagger documentation to the APIs. I've set some, these are all like generated on just the Swagger definition. And I've added the setting on how it's going to be put in. It's going to be HTTP and HTTPS, things like that. But what I've changed is actually that I have added, let's see, I have added a policy here that will validate the authorization header. So I've added a token validation, meaning that if it doesn't get validated, you will get a 401 and you will be unauthorized. So I'm checking the signing key of the token. I've added this as a named value, so it's I can get this directly from my key vault. And I have also added a claim here for admin that needs to be true. So what does this mean? Well, if you go back to Postman, I can see now this query is the same random fact one that we have for the behind the API management service. And now on this query, I have not added the token for the authorization. So if I now send it, you can see that the response I'm getting is a 401 unauthorized. So now I can't query this endpoint without actually adding the token. And I've done this here. I've added a bearer token authorization. It's encoded here. And if I press send, now I get the response that here is my random fact. And if we go back to the demo here quickly, we can see that the backend is configured. I've also added application insights to this one so that I can look at the, I don't think I've added, well, we'll see. Well, doesn't matter. Okay. If we'll see if it actually comes up here, if I do like that. Yep, this I can see that the request going through application insights, it's coming in, it's going out again, and we can actually see that it's all good. Perfect. I get a 200 from it. It goes through the application gateway to the backend, and then it returns to me with my random fact. And that's good. But what if I do the unsecure endpoint, the execute one? So here I still have my code to run and get the environment variables, and I have added my bearer token. And if I send that one, I can still get the code running on the backend. So it's not perfect. That's not what I want to do. I want to secure that. So even though I have a insecure API, I don't want random people sending unsecure code to it. I don't want them to have a command to the console or anything like that. So before we go forward to actually look at that, I'm going to talk a little bit more about the policies, because as you might have seen, it's XML, and I can say from my personal experience, I don't like working with XML. So of course, it's Microsoft Azure, so you can see that they have added Copilot here. You can use it to actually write code for you. You also have some snippets that you can just say, this is what I need. I need to get from cache or store something. I need to log it to an event hub or service bus, rewrite the response, add some retry logic, anything like that. You can add it here. They also have a GitHub page that is open source. So Azure/API management policy snippets. Here you can also look at the examples, and you have a huge list of things that you can add here. You can see there some of them are quite outdated, but they are well documented, easy to use when you have a specific case that you want to fix, and then just copy it into your policy and it's all good. They also have one for if you're using API management to put in front of your AI services. So if you have APIs utilizing AI services, you can actually go in and look at the AI Gateway repo from Azure, and that one will give you policies specifically for OpenAI and external AI services. So that's a pretty cool repo, which Microsoft are really pushing right now. So if you're developing AI apps in Azure, I would recommend you to look at the Azure AI gateways. Okay, so again, we had the endpoint here behind API management. This one is still executing the code that I'm putting in the body. And I don't want to fix my code in the backend because for some reason I need this to work, but I want it to only be for some use cases. So what I've done eventually is I have created a application gateway, and I have my front end on it. I'm pointing it to the public IP. The FQDN would be api.company.no. And I've also added a web application firewall that is enabled. It is in prevention mode, so it will block anything that it doesn't like. It is using the OWASP 3.2 one. Every rule is enabled. And if I then wanted to route my traffic through this application gateway on this new endpoint, let's look at this one. So I would still use my bearer token because it's going through the application gateway and then to the API management instance and then to my backend. So several steps here. So I'm using application gateway to just scan for the common top 10 OWASP vulnerabilities that I don't want to be utilized. I then route traffic to API management, which will check my token that I've added, and then it will send it to the backend. So with the random fact endpoint again, I'm hitting it and it works under the API FQDN that I've added. And then if we look at the unsecure one, so here's the execute endpoint that I want to do again. I have added the token, which is required by API management. It's secured there. And then let's see how it works when I have it through the application gateway and the web application firewall. There it will see the request. It has some code that it's trying to put in through the body. And I'm actually getting a 403 forbidden because the application gateway is blocking it with the web policy. So cool, I've gotten that, it works. One last thing that I want to show you guys is I mentioned Defender for APIs. Oops, that was wrong. That one. I have set it up, and if I look at for API recommendations here, you can actually see that I'm seeing that the affected resource is my backend, my web app. And here I can see that it's specifically the API, and here's the backend. So it's different recommendations there. For example, here it says that all calls to the API backend should be authenticated. Of course, this one is saying that you should use the authorization blade instead of adding it into your policy, which I have done. But of course, it gives me a description on what it is. It links to the OWASP one so that I can see what is, why is it bad to have broken authentication and security misconfiguration. I can check those links and read up and things like that. I can see that it's in the attack one, it's initial access that it can be used, exploiting public-facing applications. Some steps on remediation, automatically suggested a colleague of mine to go and fix it. And I can also add some preventions to deny it from happening again. I'm not say this is not allowed. Every API needs to have authorization or authentication set in the headers. So that was a very, very quick look on how to utilize that. it was actually the end of my demo as well. So I don't have much more from my side. Are there any questions? No, quiet.
Any questions in the chat? No.
All right. Was a bit short one, this one. Managed it in a half an hour, so that's good. Then I get to eat lunch before my next meeting as well.
Yeah, that's true. Well,
Yeah.
yeah, thanks for presenting today, Erlend. That was very good.
Yeah, we got one question in the chat now regarding restrictions set up with custom domains. So there's not any restrictions there. You can set it up with custom domains, but you need to make sure that your certificates work. If you set it up correctly or incorrectly with the certificate chain, you will get a error there. That's the only thing.
Are there any kind of, I've got a question, are there any kind of typical configurations that you can implement on the API management side just to avoid the defender alerting, just getting best practices that that you would implement?
Yeah, I actually haven't used Defend for APIs before. It's just our demo environment you, Craig, have set up quite good, just checking off every box. So it was actually just something I wanted to check if it would recommend. But from what I've seen and done at customers, we have done it through custom policies. And the reasons for that is that we utilized a tool called API Ops for actually taking the configuration and policies from one API management setup and then copying it to all our environments. So we had one API management instance per environment. So we used policies to actually set the configuration similar for everyone. And because of that, we use the policy way of setting or enforcing authorization and authentication.
Yeah. Cool.
Yeah. Thank you for the link there, Martin. Yeah, question also from Håkon. Per subscription per month up to X million API calls. So with API management, there are some different choices you can do on architecture. Like I mentioned, the customer that I worked with last on this one, they had one per environment. So one in test and one in production. It can be done like that. Of course, there's a cost. API management isn't cheap if you want to go for the more premium SKUs. For example, with the classic SKUs, you need to have premium or the developer one. I think as well you can get private networking. The developer one isn't SLA, so the premium is your choice. And then you have the V2 SKUs, which is the new types. You can get SLA and private networking with the standard one, which is a bit cheaper, but not compared to the or developer SKU. So I mentioned that there are two ways. You can also have it as a central service that you have one API management and then utilize either workspaces or self-hosted gateways to separate the different environments so that you can have one configuration for dev, one for test, one for production. So It depends what your requirements are. If it is to maximize security, I would say go ahead, separate them into different subscriptions. But if you want to minimize the costs, I would recommend to have one central one, a platform service, for example, where you have the API management and then use workspaces to separate the different environments. Any API management policies you would recommend the most APIs in API management? Most one. So if it's a public one, I would recommend to utilize some sort of logging. So you can, there's a policy that you can use to log the entire query to or some fields to a service bus or a storage count, so that you get a full overview of who has actually gone and requested through it. That's one that's pretty cool. But for the most common one, yeah, either that or the rewrite of the endpoints. If you're routing it through front door or application gateway, you will have some rewrites of the host name from the requester and some tokens. Often there's a policy there that you can utilize to actually fix those headers so that they're correct and the endpoints or host names are correct when you get it to the backend, just to verify it, and because it can create some issues with cross-origin resource sharing. That's the one that I can think of, at least. Possible to protect external on-premise hosted APIs with API management. Yeah, you can. So with on-premises, you can use the self-hosted gateway, or if you have it in another cloud, you can utilize the self-hosted gateway, which is a lightweight container that you can connect to the API management, and it gets its own custom domain that you can use to route through traffic. You can also place it inside of a Kubernetes cluster if you want to minimize the network, or you don't want it to go all the way outside the Kubernetes cluster to get to the API management gateway. So you can place it inside there as well. I know that externally hosted APIs, I mentioned the AI gateway. There, Microsoft recommends to utilize API management to external services as well. So I can find a link for that as well. So there are many cool examples in this repo that Microsoft has set up, and that's also for securing external AI APIs. So if you're using an external one and you want your applications to talk to that, you can host it through API management and add some extra functionality like content filtering, for example, or if you want to log the use there, and you can even log which application is using the tokens, or you can do rate limiting and throttling based on the tokens. So if you want to cost management your external AI services that you might be paying for by the token, you can host it through API management, that external one, so that you have full control of who is using your tokens.
Really great questions, guys, coming through. Are there any more questions? Okay. Well, in that case, then, I just want to say thank you very much, Erlend, for a great presentation. Thanks to everybody for asking some good questions at the end. And we will see you at the next meetup in the new year. And look out for the recording and slides on our LinkedIn channel over the next few days. So thanks very much. See you all soon.
Thank you. Bye.
Bye-bye.